Welcome, ladies and gentlemen, to the first video among the series of videos where we will talk about blockchain. So, what is blockchain? There has been a lot of curiosity, lot of hype around this. There has been notion that this is completely going to change the way the world works. It's going to make world a better and safer place. So, let's deep dive into it. In this first video, I will introduce you to the world of blockchain. I will give you insights on how it operates, and it will help you to better understand what the technology is all about. Let me start the presentation. Meanwhile, the presentation is starting. I'm Jitin Fernandez. I'll give you more details about me. So, blockchain, as you can see on the screen, blockchain is made up of two words, block and chain. So in real world, when we think about chain, it is a series of metal pieces tightly coupled to each other, and if you try to remove a piece from between, it is difficult. So they are tightly coupled to each other. Now in this screen also, if you see, there are blocks which are tightly coupled using chain. So blockchain is nothing but a series of blocks tightly coupled like the way chain is. And if you look closer inside each block, you can see record/transaction. So essentially, what we can make out of this is there are a series of blocks, and in each block lies record and transaction. So this is how we can at present deconstruct what blockchain is all about. Let's go further. So the current notion in the market is that it's the next big thing. People are saying this is going to be bigger than internet. I mean, in our knowledge, in past 25 to 30 years, internet has changed completely the way we operate. Things have become much simpler with advent of internet. With internet, everything is at the tip of a finger. Now, the people are saying, or there is a hype that this is going to be bigger than internet. So that is something, and it would be really good if we know what is blockchain rather than staying away from it. So that is what we are going to do in this presentation. And also, this will be the start of fourth industrial revolution. With the advent of blockchain, everyone is speculating. The industrialists are speculating, the corporate houses are speculating that this is the start of fourth industrial revolution. So indeed, it's very big. Let's move to the next slide. To talk about me and blockchain, firstly, I am an IT professional. I have been in this industry for last 12 years. Currently, I am IT project manager in Dubai. So how did blockchain happen to me? So firstly, I had heard the word blockchain years ago when Bitcoin was a hype. I knew that the technology behind Bitcoin is blockchain. Until a year back, I was going through TED videos. I was going through one particular video came came in my searches, and it said about how blockchain can change the rural community in India. By the way, I am from India. So I was like, Bitcoin technology, how it can benefit rural India. I was like, I got really curious and I went through that video. It got me so energized around it. I was like movie marathon. I was completely sitting days together, spending weekends together, just back to back, searching videos, reading about blockchain. So yeah, so that's where I started gaining knowledge about blockchain. Then I was like, I want to learn it in more professional level and in more classroom oriented training. That's when I got myself blockchain certified. So that's about me and blockchain. Let's move to the next slide. So the definition, I'm going to read out the definition, but don't worry if you don't get anything around it. I will deconstruct it for you. And with an example. Once we go through the example, we'll come back and read it again. So the definition says a blockchain is a decentralized, distributed, and public digital ledger that is used to record transaction across many computers so that any involved record cannot be altered retroactively without the alteration of all subsequent blocks. I know completely Greek and Latin. Let's do this. We will pick up one by one word which I have highlighted in bold. So it says it's decentralized. Okay. Distributed, public ledger, cannot be altered. So these are the four terms which is the foundation of blockchain. Let me take you through this through an example. I will launch Microsoft Excel because let's take a normal example and let's try to understand blockchain. Now you have to be very attentive here because now to understand blockchain, you have to give complete focus because this is something new. So it will take a while to digest. So be attentive here. Okay, so I'll just give the gist around the example. Let's take the Girls Gang of Friends series. So suppose Monica, Phoebe, and Rachel are living together. Okay, so what they do is they live together, and all the expenses at the end of the month they reconcile and pay each other. So that is the scenario. So in the first scenario, assume, I'm just gonna highlight. No, I'll use a different color. A lighter color. Okay. Okay. So this is Monica, Phoebe, and Rachel. Suppose in scenario 1, each of them are maintaining their separate accounts. Okay, whatever transaction, monthly expenses they do, they are maintaining it separately, and at the end of the month they reconcile. Monica and Phoebe do maintain in it in their own ledger, while Rachel, what she does is she has kept an amount aside. So suppose $5,000. Okay, and wait, I'll just put the dollar symbol. And she says, if at the end of the month I have 3,000 left, that means I have spent $2,000, and then we will reconcile. So now assume Monica spent $1,000 on groceries, okay, and recorded that in her ledger. Then Rachel, I'm just putting it here, but she transacts differently, as I said, paid 1,000 for electricity. Okay, anyway, let's go. Then Phoebe paid rent of $5,000. They wanted a new TV, so Rachel spent $1,000 on TV. Let's see, Monica spent $2,000 on everything else, maybe like internet, cable. Okay. For simplicity's sake, 3,000, 8,000. Yeah, perfect. I'll make this 500, 500. Okay, because then it will be easier. So if you see, for the entire month, 3,000 of Monica, Phoebe's 5,000, and Rachel spent 1,000. So that constitutes to $9,000. Per person should spend 3,000, and Phoebe has spent 5,000. So Phoebe will get $2,000. Okay, and Monica has spent 3,000, so she doesn't have to pay, and Rachel has to pay this 2,000 to Phoebe. So if you think in a broader picture, this is what happens. Right now, in any transaction, let's take example of farmer. The farmer sells its produce to an intermediary. Intermediary sells it to a wholesale retailer. Retailer Wholesale retailer sells it to a supermarket, and consumers buy it from the supermarket. Now each have their own ledgers. The problem with this is, if Monica says, if comes and says that I spent 2,000 in groceries, we have to believe, because that's Monica is doing the bookkeeping and Monica has recorded that. And in case of Rachel, she is with the assumption that she is using this account only for this purpose, and whatever is left, that should be subtracted and that is spent. So that is based again on an assumption, and there is high chances that this particular record can get corrupted. Okay, so everybody is having their own centralized ledger and they are maintaining it, and they can alter it. It can be hacked and entire system can go for a toss. Okay, then considering the scenario was not going well, Monica comes up and says, hey, this is not going well, let's use Google Doc. Now we are going a step ahead, where all transactions are recorded in Google Docs. So the issue of transparency here, I mean, since everybody were having ledger, gets sorted out. We have one single Google Doc created by Monica. She is the admin. Okay, and all the transactions they do will be recorded here. So we will just put the same transaction with the name. Okay, so Monica spent $1,000 on grocery. Okay, grocery. And Rachel, we made it 500, right? Rachel spent $500 on electricity. Then Phoebe spent $5,000 on rent. Rachel spent $500 on TV. Okay, and Monica spent $1,000 on others like internet, cable, etc. Same philosophy, and at the month end they reconcile. So Phoebe gets $2,000 from, I mean, they'll reconcile, and the respective amount Phoebe will get from Monica and Rachel. Everything is fine. Let me just sum up and see. This is 7,000. I'll make, this was 2,000. Yeah. So sorry. Okay. Everyone is happy because everybody can see what individual person is doing. Now we have a unified ledger. Assume for a scenario, Rachel goes and does this. She makes her transactions into 1,000 and reduces Monica's transaction into one of the transaction from 2,000 to 1,000. And then at the end, Rachel claims that I have to only pay $1,000 to Phoebe, and Monica also has to pay $1,000 to Phoebe. So even though it is transparent, it is prone to such changes. Now there is a huge debate around it, and Monica, being the admin, she goes ahead and deletes the Google Doc file. So that, what is that? That is, Monica was the centralized authority. She went ahead and deleted it. So all that was recorded is gone for a toss. So the second sheet, even though it solved the transparency problem which was not in the first sheet, it still had it was still centralized, it was still prone to attacks. Now let's see what blockchain does. Blockchain is a series of blocks connected to each other. Okay, this is what we understood. Wait, I'll use a different color. Okay. Uh, Now consider there are, this I'm putting just to give you a feel that there are blocks in between them. Okay, so it's blockchain is a series of blocks connected to each other. Okay, now what happens? How blockchain works? And for that, you have to assume everybody is on blockchain. This is an ideal scenario where you are expecting the grocery guy, the electricity guy, Monica, Rachel, Phoebe, all transactions are on blockchain. Okay, so the first transaction is what? I'll just copy this so that, okay, so the first transaction is Monica is sending $1,000 to the grocery person. Okay, so then this is considered as a transaction in blockchain. Monica is at the one end of the transaction, the grocery person is on the other. Whenever a transaction is generated, it is tagged as uncommitted transaction. So we'll say this particular transaction is uncommitted. Now there's a concept called as miner. For now, just assume miner as someone who collects these uncommitted transactions and tries to create a block. Now, when a block gets created, this particular transaction is also included in the block. Now, that's not it. Once the block gets created, propagates the block across the network. Okay, and a network has series of nodes. Until the series of nodes agree to it, then the block gets committed. Let me take you through a concept of hash. This again we will dwell in detail. Hash is nothing but it is a software, one sided encoding mechanism where if you give one input, it's a one-way street. You give one input, it creates a random key of output. The moment I change this, it will completely change the key. Meaning, any small alteration in that particular value will end up creating a new key. So for Jitin, if this is the key, every time when I encode using a particular algorithm, it will create this output. Okay, so every block has a hash value, which will be a random series of alphanumeric variable value. Okay, now when you enter the block, first thing what it does is the current block has a reference or the hash of the previous block. Okay, so this is the hash of the previous block. At the same time, it will have a hash of its own. Now, how that hash is created? The hash is created by hashing all the transactions. Likewise, I'll just put the details here. I'll just copy this. Oh, sorry, command. Copy this and put it here. And suppose Rachel makes $1,000 in dollars to electricity. That transaction resides here. Oh, I don't know why I did it green. I'll make this blue. This as well. In some other committed block, we have Monica's this $1,000 with previous block's hash and the hash of this particular block. And this particular blockchain can be viewed by all. If you go ahead and search for this block, entire list of transactions that has happened, from whom to whom the transaction has happened, everything would be available. Now, let's take earlier issue. One was if Rachel tried to alter the amount. The moment you change the value, what happens is the hash of this block changes. Now the hash of this block, sorry, this is the value, changes, but the hash of this block is committed here. So that's why, if you remember the definition, it said you can't change the value of the block until you change the value in all the subsequent blocks. To add to the trouble, this particular blockchain doesn't reside in one computer. It is spread across all the nodes. The moment a block is committed in the blockchain world, it gets propagated to all the nodes. All the nodes have copy and is identical at real time. It consists of entire blockchain. At present, in my knowledge, there are thousands and thousands of block nodes in Bitcoin world. That means you have to go ahead and change. And moment you end up changing one block, it will not be accepted because the reference is there in the earlier block. That means these records, once committed into the system, it's near to impossible to change the value of any block that is committed to the blockchain. Also, it can't be muted because this particular copy sits in entire system. Every node has a copy, and it is completely distributed, completely decentralized. So one operation which Rachel did, that is editing the amount, is not possible in blockchain, and Monica, being the admin, went ahead and deleted that, also is not possible on blockchain. So that's the beauty of it. Now let's go back to the presentation and try to read through the definition again and see whether it makes sense. A blockchain is a decentralized because nobody is admin here. Distributed because every node has a copy. And public digital ledger because everybody and anybody can see what is going on in the system, completely transparent. That is used to record transaction across many computers so that any involved record cannot be altered retroactively. We saw it is not possible to alter without the alteration of all subsequent blocks. Now I hope this definition makes sense to you, because this is essentially what is blockchain. Let's move to the next slide. So the first live manifestation of blockchain is Bitcoin. I will take you through this Bitcoin and Ethereum concepts in detail in the next video. For now, these are the important points of Bitcoin and Ethereum. So a person called Satoshi Nakamoto, he came up with a white paper, and his vision was single digital currency worldwide. It was, I think, in 2008, and 10 years later, one Bitcoin's current value is around $8,000. It's written 867, but this keeps fluctuating a lot. So when you see this video, the value might be different. I told you about miners, which create the blocks, which collect all uncommitted transaction and create the block. Whenever they create a block, they are awarded 12.5 Bitcoin. So you can imagine that would be $100,000 for creating one block. So that is the reward a person or a company, whoever successfully mines a block, he gets that much. So that is a huge amount. Okay, and at present there are around 7,000 plus nodes. That means there are around 7,000 copies of the blockchain. in Bitcoin world. And Ethereum again is a cryptocurrency, but there is something more to it, which I will take you through in detail. Okay, currently Ethereum is valued at $157. So the coin or the currency in Ethereum world is called Ether, and it is valued at $157. And in Ethereum, unlike Bitcoin, which is purely for transaction of uh, cryptocurrency Bitcoin, Ethereum has gone a step ahead, where you can code and make applications in Ethereum. So those are called smart contracts. We will see about it. And in Ethereum world, mining is faster compared to Bitcoin. Don't think too much around this. I will take you through this in detail in the next session. Okay, moving on. Use case number 2, self-driving cars. I've taken this use case because we can relate to it, because everywhere we can hear self-driving cars are coming up. Also, if you remember in Fast and Furious 7, I guess, um, they had shown a manifestation of self-driving cars, and in that they showed that someone went ahead and hacked all these self-driving cars, and they were falling off from building parking. And when I saw the movie, I was like, okay, it can be hacked. Let me just put few foundations of blockchain, and we will think about this use case a little more after seeing through them. Okay, the primary principles which I have put down here is nodes can come and go in blockchain world without any impact. These nodes, I told you, right, there are around 7,000 plus nodes at present in Bitcoin world, and these node counts randomly varies because anybody can come in this blockchain at any point of time and leave the blockchain at any point of time. Now relate to this. Each node is a car on that particular expressway. Anybody can come, and any car can come, and any car can go. Take it stepwise, don't think much. Let's go to the next point. All nodes in the blockchain are in sync in near real time. I told you, right? The moment the block is uh, generated, it is propagated to all the nodes, and until there is a consensus, the blockchain node is not committed. Once it is committed, everybody has the copy in real time. So any decision, like a car is planning to take a left, that is a transaction, and unless that transaction is committed and mutually agreed by all other nodes, which are other cars, it won't be committed. So and everybody will be in sync. The moment everybody in together agrees that okay, this particular car can go left, it won't happen, and once it takes left, everybody is aware the car has taken left. The third point I already said, a block is only committed once consensus is achieved. Blockchain is distributed and immutable. Like I said in the movies Fast and Furious 7, hacking is very difficult here. To change a particular instruction which in blockchain or a transaction is in blockchain is very difficult, because everybody has a copy. If you have to hack, you have if you have to change, first of all, you saw the blockchain world, anything you change, the hash changes. So first of all, changing a block is difficult, and if at all you change all the blocks, changing it in the array of nodes which has a copy is almost next to impossible. So if you think in self-driving car perspective, every car is a node. Every action taken by any of the cars in that array of node is a transaction, and unless all the cars agree to it, that transaction will not happen and once that transaction happens, everybody knows it has happened. So any car taking left, taking right, every other car surrounding it is aware. So with this concept and with other complexities, self-driving car looks a reality right now. In fact, GM and BMW now, with incorporating blockchain technology into their self-driving car, thinks that these vehicles would be tested and will be approved and on the road sooner than they were earlier expecting. So self-driving cars much a reality with blockchain in picture. Let's take the next use case, which is supply chain management. Now, supply chain management, I mean, import export is a massive multi-million trillion zillion dollar business. Okay. And like I told, current system, everybody has their own ledger. That results in two issues. I will take the second one first, lack of transparency, because everybody is uh, owning their own ledger, and lack of authenticity. I'll just give you an example. Suppose a particular company has a e-commerce website, or an e-commerce website sells multiple products. Now, a e-commerce website can sell a shoe claiming that it is of a particular brand. We as consumers think it is, but there can be a scenario that we are getting a first copy. To give you a real life example, cheese, certain cheeses like Parmesan cheese, apparently most of it in the market across globally is not the authentic Parmesan cheese. And it's, I think it comes from somewhere in Italy, and the government is trying ways to ensure that this market, which is a $1 billion industry, okay, the fake cheese market is a $1 billion industry, how to tackle them. So authenticity is a problem. Now, if I buy a diamond, how will I be sure that I am buying the authentic diamond? Okay, so here also blockchain comes to rescue. What now blockchain is suggesting is digitization of asset. In the sense, consider a diamond, which currently is happening. The one which I have mentioned here, De Beers Sa Diamonds. This particular company is already on blockchain. What they are doing is each diamond they create is digitized, in the sense multiple parameters give a unique identity to that diamond and is put in blockchain. Whenever a particular person has this diamond, wherever you validate this diamond in blockchain, you will be able to identify whether this is authentic or not, because the digitized information of this lies in the blockchain. And when you digitize the diamond which you have, and if they claim this is the one, both the digitized value should match. So this is how this particular company using blockchain is giving authenticity. And uh, in the supply chain management, one other issue is the food trust. In the sense, now consider a high end hotel industry or a high end restaurant. They claim this Parmesan cheese is authentic. We are in their menu, it says Parmesan cheese ravioli. We trust, okay, they will give us Parmesan cheese itself. But in the supply chain management world, I mean, like in somewhere in the system, someone would have gone ahead and induced this cheese, which is exactly not authentic Parmesan cheese. So IBM has come up with a blockchain version called as IBM Food Trust, which means again every food item would be digitized, and from the starting point, that is from where you get the food item, from where it is produced, every other step that happens until it reaches a plate will be in the blockchain world. And if anybody has to look back, like the chef has to validate from where this cheese has come, he has to just backtrack the history, because everything will be on blockchain. So if some guest comes and says, prove that this is the cheese which you are using as is Parmesan, IBM Food Trust, you have to just backtrack the cheese which you have used for creating this. So using blockchain, supply chain management can be completely disrupted, and for good. Everything would become transparent. So companies are already embracing it, and I believe going ahead you will see more and more big companies coming in blockchain. So that's the next use case. Okay, that brings us to the end of introduction to blockchain. Just to summarize, blockchain or distributed ledger has a potential to revolutionize every transaction that happens. And the initial vision was to have a one currency, digital currency, so we can do away with the fiat currency which each country has, to a one centralized digital currency. This also would result the move from a centralized mechanism, everything is centralized right now, to more decentralized world, because nobody is owning anything, everything is on blockchain. In the sense, every data is available and for public viewing, and everything is decentralized. Hacking, ransomware attacks will be the thing of the past. Authenticity cannot be forced. Once everything is on blockchain, everything will be tokenized, everything will have a digital identity, and it can't be altered. So Fred Urson, he is one of the co-founders of Coinbase. He thinks everything will be tokenized and connected by blockchain one day. With this vision, I am ending this video session. I hope you all got a fair idea about blockchain, and I hope everything, I mean, you all are thinking, because first YouTube video when I saw it kept me thinking. So please wait for my next video where I will be talking more on blockchain and Ethereum. That will give you further insight into the blockchain world. Thank you. Bye.